Metals have long been the dominant manufacturing material, but ceramics are growing fast. If you're a machinist, you might be thinking ceramics are tough to grind. But are they? In this episode of the Grinding Chronicles, we're going to find out.
Welcome to the Grinding Chronicles, presented by CDT Application Engineer, who we call Optimum Prime, also known as Harrison Sheldon.
Hi, I'm Harrison Sheldon, Application Engineer at CDT. For this video, we're debunking the idea that grinding ceramics is especially difficult. While some ceramics can be tough to grind, that's not always true. To explore this, we ran a trial to measure just how challenging different ceramic materials can be. We looked at the power and the force it takes to grind them effectively, then compared these results to various metals. With this experiment, we hope to provide useful insights for grinding ceramic materials. But first, why do ceramics get such a bad rap? Well, technical ceramics fall into three main categories: oxides, like alumina and quartz; non-oxides, like silicon carbide and boron carbide; and composites. Composites combine metals, oxides, and non-oxides with particulate or fiber reinforcement. For example, zirconia-toughened alumina is a composite. Held together by strong ionic or covalent bonds, ceramics are typically strong and hard, but often brittle. I know, that doesn't sound good for grinding, but let's look at the trial. Of the thousands of ceramic types, we chose 4 random materials: boron carbide, quartz, silicon carbide, and zirconia-toughened alumina. Each was cut using the same 240 grit vitrified diamond wheel in a surface grind. Sensors measured the power draw and cutting forces. Why are these important? Well, power is used to calculate energy, which determines the grind zone temperature. The higher the temperature, the faster the diamond degrades, wearing down your wheel. Measuring force is critical too. If the force gets too high and the machine isn't stiff enough, it can deflect or vibrate, which increases wheel wear, machine stress, and quality issues like cracking. As you can see in this table, showing our trial parameters, we varied the feed rate 3 times, which gave us 3 different material removal rates. Let's look at the results. First, we measured specific power and plotted it against material removal. If you're unfamiliar with specific power, check out episode 9 of the Grinding Chronicles. Here, we see boron carbide required the most power, while quartz required the least. Next, we plotted material removal versus force. You'll notice in this work removal graph that ceramic materials rank the same as they did in specific power. Finally, we compared data from both graphs to demonstrate cutting performance, which basically tells us how easy or difficult these materials are to grind. We can see here that quartz is so easy to grind that it doesn't even fit on the standard chart. So what's the takeaway? For starters, not all ceramics grind the same. Like metals, some are easy and others are not. The difference is that more people are familiar with the properties, processes, and difficulties in grinding metals than ceramics. So ceramics aren't as daunting as they seem. In this 1970 study by Dr. Richard Lindseay, you can see the relative difficulty of grinding various metals with conventional abrasives. Notice that our data for grinding boron carbide with vitrified diamond is only slightly more difficult than grinding 52-100 bearing steel with a conventional abrasive, while ZTA with vitrified diamond grinds as easily as cast iron with a conventional abrasive. There are plenty of differences between grinding metal and ceramics, but from a power and force standpoint, ceramics have cutting performance levels similar to metals. The key to grinding ceramics, then, is understanding the best process, machine setup, and wheel to use for that particular material. If you're new to ceramics or having difficulty grinding this material, our engineering team is here to help. Reach out today at the Grinding Chronicles at cdtusa.net.
Thanks for watching. If you enjoyed this video, hit that like, follow, and subscribe button, and get ready to learn something new in another episode from Continental Diamond Tool.